whole entirely separate set. You have Mr. Tony Stark, Mr. Steve Rogers, Ms. Natasha Romanoff. These guys are all owners of their respective businesses, right? But you'll notice that owners is separate from users, right? So what if I want to see all of my users? Because an owner is technically a user, right? They have the exact same columns, they have the exact same things. There's other than what we use them for, there's no difference between the data of what they are. So what we can do is we can create a union. So we can do select all from owners, and then we can do we can use the union command, and then select all from users. And if we do that, wow, my bad, typo. I'm like, well, am I losing my mind? Okay, sorry about that. All right, so you'll notice here now that our table contains all users and all owners combined. That's what a union is. We're taking tables that have the exact same amount of columns, that have the exact same data set, and we're combining them. So, yes.
We have a question from Facebook Live from Eric Sandoval.
Sure.
He said, can you explain the difference between rational databases and NoSQL?
Yeah, I did earlier, but I'll finish this part here, and then afterwards I'll kind of go back and reiterate the difference on that. So basically what we've done here is a very basic example. As long as your two tables have the exact same columns and have the exact same data in those columns, you can combine them together, and you can get a concatenated list. You can do a lot more with it, but at a high level, this is what a union is. Later on, if we decide to have more of these later, we can go and do some really cool stuff with it. But essentially, at a high level, what we're doing is we're taking two tables and we're combining them together, right? So
when you do the union, it's the distinct, right? So if there is an owner that's there in the users,
yeah,
it will not return. If you do union all,
right? Yeah. Yep. Like I said, this is just a very basic example. It's just taking data types between two. As long as they match, you can combine them together.
By the way, Armando, you have more time. You're fine.
Are you sure?
Yeah.
Okay. All right. So let me move on to the next part here, and let's see. So we have this other table here, which is orders. As I mentioned, we have our orders. From orders. So we have a couple of orders here for a couple of users, from users 1 and users 1, 2, and 3. So there's a lot of things that we can do here. So let's go into, let's say, for example, we want to get the total number of orders for a particular user. So we can use our same query that we used earlier, select all from orders where user ID equals 1. So what this is doing is it's grabbing every single user ID or every single order that has a user ID of 1. Okay? So what we're doing here is let's say this is great and all, but let's say I want to get I don't want everything, I just want the total. So we're not going to use this select all from. We're not going to use that. What we're going to do is we're going to say the total. So if we do that, we're only going to get the total table. This still isn't exactly what we want, because we want to get the total amount that the user spent over the month, right? If you guys go on, I don't know, like your bank accounts or something, it'll give you a total, like you've spent $20,000 or something. You spent way too much money. Stop it. So what we can do is we can do this. We can set the sum of total, and now it returns the total amount. So this is really basic data aggregation. This is a very powerful tool. You can go into things like using deltas to define user points. You can modify points. You can modify $signs. You can add percentages. There's a bunch of different things you can do with it. But at a super, super high level, the most common thing you guys are going to use is going to get a sum of total data, because when you're displaying data to a user, they want to see the total number of points they've accrued. They want to see how much money they've made. They want to see the total amount of records that they've sold, or whatever they want. This is how you would do it. So this is great, but how do we define this to a user? Like, how do we combine this to a user? Because it's not, obviously if you look at our table here, we have a user ID, but what does the user ID, like, what is, like, in context of this table, what does it mean?
You're going to join with your user table.
We're going to join. So with that being said, so the next thing that we're going to do is we're going to join. So joins are something that you're going to use a lot, especially with relational databases. The whole point of a relational database is to have relations. There can be one-to-many, one-to-one, has many, has one, whatever. I'm not going to get into that type of stuff today. That's for a topic of later times. But the whole point of using a relational database is to have relations across your models. That's how you control it. That's why you don't have tables with 50,000 records in it. That's how you maintain, cleanliness, I guess, is the best way to do it. So the first thing we're going to do is we're going to do our select command. And rather than doing just select all from, we want to aggregate our table. We want to build our table specifically to how we want to structure it. Let's say you want to build an API, and this API only needs to maintain a certain amount of things. It needs to have the order number, or maybe just the total, and then the name of that user. Okay. So what we're going to do is we're going to select all from orders dot total, right? So what we're saying here is we're saying we want to get from the orders table, which we'll define in a minute. We want to get from the orders table just the total. Okay. But what we want to do is we want to get the total for the user, and we want to get the user. Let's say we'll get the user's email. So we're creating an API structure that's getting the user's email. We're getting the user's email and the total of the orders that they have, and we're combining it into this new aggregated table. So where we define this orders is we're going to say from orders. So we're telling select orders.total. So now our SQL command knows what table to grab the data from. So we're going to say order, and now this is where something you haven't seen before. This is something where, oops, I should probably also add my from. So from orders, now this is what we're going to use. There's different types of joins. There's inner join, left join, right join. We're only going to focus on inner join today. That's the most common thing you're going to do. So we're going to inner join, and what we're going to inner join on, we're going to inner join the users. So what we have here is we have select our orders total and our user's email from orders. But what we're going to do is we're going to join the orders table with our users table in order to combine our data to create a brand new record or a brand new query statement. So we're interjoining on users. So how do we define the connection between the orders and the users? So what we do is we say on. So we're saying on the orders table, on the users table, what we want to do is we want to get the orders.user ID, which is our foreign key, which is our reference. I'll explain that a little bit later. We have our user's ID, and that user's ID is going to equal our users.id. Okay? So when we use this command, oops, hold on. Let me go ahead and flip this up a little bit because I messed up my query. There we go. Okay. There we go. There we go. Okay. So when we run this command, we now have our totals and our emails for all of our users. But you'll notice something. We have all of our tables. You have J. Allen, we have P. Jacobs, and we have K. McNeil. So this is great, but do I really want an API that's going to send back multiple records and then have the front end go in and sanitize it and filter it however? Nah, that's too much. I mean, I wouldn't mind it. They can do more work, but we're trying not to get fired and we're trying to keep our friends. So let's do that. So what we're going to do is we're going to use the keyword group by. And so group by basically means you're going to take all the records that are the same and you're going to group it on a specific column, right? So in this instance, we're going to group it by users.email. So when we run this command, what's going to happen is you're going to see our records are down to 3. And now what it's done is it's broken down our J. Allen, P. Jacobs, and K. McNeil into 3 records because it's combining it. But we have a problem. Our totals are off because it's only grabbing 1, right? Obviously, that's not going to work. So what we can do is, remember earlier we did that sum, right? So we can say sum orders total. And now we have our totals with our records, and it's nice and clean and sanitized. We can convert this to JSON or XML, whatever you guys want. We can pass it off through our API, and everybody's happy. This is obviously a very, very basic, high-level explanation of the general idea of MySQL. I know it kind of went rapid. I didn't have a whole lot I was trying to keep it minimal. If I knew I had more time, I would have put a little more details into it. But with that being said, this kind of concludes the overall presentation for the SQL portion of it. If you have more time, I'm more than happy to answer any questions.
Is it just preference that you don't capitalize your statements?
Yeah. I have my CTO always gets mad at me because I never capitalize on things that I do, but he specifically wants it. So typically, I guess this goes outside the scope of SQL, yeah. But generally speaking, when you work on a team, you always want to stick with consistency, and you generally go by consistency and what the tech lead dictates. So if the tech lead says, I want all of my variables to be camel case, I want all of my SQL to be capitalized, you do that.
Yeah.
Not because you agree with it, but because it has to. You have to maintain consistency.
I mean,
across
it's
your
nice
code.
in here because it's highlighted.
Yeah. So
it's
for me,
nice in here because it's highlighted, but if you're in a terminal space,
yeah, if you're in terminal, it's going to be hard. It's going to be hard to read. I've personally just done it this way, just because I'm lazy. I have no other reason for it. What's up?
Another question from Eric Sandoval. What does sanitize mean?
Sanitize? It's just a term that basically means that you're cleaning up your data. You're making it presentable, or you're giving. If you're giving an API response on the front end, it requires or expects an int, then it should be an int. Or if they're expecting it like a user's object, they should get a user's object.
Making sure that confidential information is not displayed.
Making sure that you're not passing passwords in with the user's object is another thing. You're making sure that you're structuring your data so that way when you pass it off to the front end, it's perfect. It's usable. They don't have to filter it out. They don't have to do anything with it. And you certainly shouldn't be passing in API keys or passwords or any system critical data, things like that.
Do you want to go over that other question that he had?
Do you have any recommendations for good resources for delving deeper into SQL, MySQL?
Honestly, the dev.mysql.com has a lot of really good documentation. Some of it kind of is out of date. There really isn't a whole lot of information out for SQL, at least something that's modern. A lot of it's from like 2015, 2014, 2008, which is fine for the most part because the language has been around since like the 70s, so not much has changed. But there's a lot of best practices and modern practices that have been adopted over the years that they're kind of missing on. The documentation from MySQL.com or dev.mysql.com is probably the best. There's a lot of other stuff. I can give you a list of things.
I think has a course.
Which one?
Pluralsight?
Pluralsight, Udemy have courses on it. As long as they're from like 2017 plus, they should be fine. I have a couple of like the documents that I follow whenever I'm working. I can Slack those. You guys can take a look at it.
I just started learning this like a week and a half ago.
Oh, fine. Welcome to the world of relational databases. Sweet. The question was
the difference
between
relational and
NoSQL. So the difference between them it really comes down to how the data is structured, right? The biggest difference between MySQL, or not MySQL, but the difference between relational databases and NoSQL is that the relational databases are structured. They have a defined schema. When you create your database, you're creating your users table, you're defining your objects, or you're defining like what the variables are. If a name is going to be a varchar, it's going to be a varchar. That's what it's going to be. If I need to go back in and I need to add another table to my object or to my data object, then I need to actually go in and modify the database directly, either through a migration or manually typing in the database and updating the record so that it's available. With NoSQL, there's no structured schema. There's no defined. There's no normalization. So when you're defining like a user or a data object, that data object is dynamic. It can change. It can grow. If you decided on a whim you want to have an address object, that's totally fine. You can add the address object. All new records will have that address available to that user. Previous will just have it null. So there's no structure. It comes down to like what you prefer. For me, like NoSQL is great for rapid development or for like just you gotta get something out. But it gets kind of crazy because if you're not following your structure, you can have really messy schema for the objects that you create. But those are really the main differences between the two. They both store data. There's zero performance difference. If anyone says that there's a performance difference between NoSQL and SQL or relational databases, they're kind of wrong, but they're also kind of right because it's situational. It depends on what you want, right? For complex queries, multiple joins, multiple relations, multiple transactions, a structured system like SQL is always going to outperform something like SQL or NoSQL. So in that sense, yeah, the performance increase is better that way. But for big data or for massive data sets, millions of records, things like that, NoSQL is the better option there because you're going to have faster read writes. Yeah, because it's going to read write faster to the object.
He said, what benefit does it have? Would it crash your code, like if you're expecting an integer and get a string?
In regards to a relational database?
Yes.
What happens if you're expecting an integer and you get a string?
Yeah, so you'll get a dreaded MySQL or SQL exception error. Depending on how you handle it, a good programmer will handle exceptions well. So the client will never see a crashed application. They'll see an oops or something. But generally, yeah, if you're passing in a data type that doesn't exist on the data or if it's incorrect or if it doesn't match, on a relational database, you would ultimately experience an exception.
That's just like programming too.
It's just like programming. Like you should always handle your exceptions. You'll always get errors. You'll always get messages. How you handle them is how you handle them. But depending on what it is you're doing, like it won't crash. If it crashes your app, that means you need to handle the exception.
He said for NoSQL.
Sorry?
For NoSQL.
For NoSQL, that's one of the benefits because you can add a record, or you can add a data to the data type of that object, and every proactive user that inherits that object is going to null it out automatically.
But you still, even in NoSQL, you still can't pass an int to a string.
Right. Yeah. Sorry. Yeah. You still can't. You can't cross the streams on that sense. You can't. It has to. It still has to still be defined in one way or another. You know. So. But yeah. You had a question?
Yeah, if there was a revoke exception.
Sorry.
Revoke?
Revoke exception?
What's that?
A revoke exception means that you're trying to access like a data type that, or not data type, but you're trying to access something that you don't have privileges to, or you've been revoked. Privileges have been revoked. That's more of like on the DCL or the data control language section of it. So that means that like you don't have the correct permissions or the query for that revoke as well.
You can let different people do different things to your database. So you can have like the administrator who can do whatever he wants. You can have an account for a user where all they can do is add stuff. You can have an account for a user where all they can do is look up stuff. If the person who can only look up stuff tries to add something, they're going to get an error.
Oh, okay.
You have a question?
Yeah. So, when you're talking about, I think maybe I'm hearing it wrong, but like with MySQL or NoSQL, if I have a table, it's going to end up having a million bits of data.
Yeah.
Is MySQL relational database okay?
Yeah.
This could
So.
be for medical offices.
Yeah, so this goes down into like what your specific use type is or your use case is, right? For transactional databases, all databases are designed to handle as much as you want. Like
Yeah,
you can,
I was
yeah,
misunderstanding.
no, yeah, you can use it. I have a ticket redemption system right now that's running, and it's using a relational MySQL database. Well, it's actually using MariaDB or InnoDB, but it has. I did an audit like two weeks ago. I think it was like 3 million records or something. And I mean, the response time on our dashboard is still like 700 milliseconds.
If you've got like 2 minutes afterwards, I'd like to.
Sure, I'd be more than happy. Are there any other questions or anything?
Oh yeah, one more.
Sure, yeah.
How would you handle your front end, like a form sending malicious code to your back end, or more, what would you do to prevent it?
So the front end shouldn't handle any of that. I mean, technically the front end can sanitize data by escaping HTML or escaping special characters. But typically on the server side, you would also want to escape special characters. So that's on the database side of things. The database, as I mentioned before, it's declarative, so it's just going to accept exceptions. It's going to accept instructions. However, whoever gives it doesn't care. As long as it has permission and as long as it has a valid valid statement. So the way you want to handle that is, of course, sanitizing your input. So a typical use case would be like on the front end, you don't escape strings and you type in, I don't know, drop all tables or something like that, and you submit that as your username. And so if you, on the back end, on your server, depending on how you're doing it, if you're not escaping your special characters or escaping those those commands, what's going to happen is it's going to send the drop all tables command to your database and it's going to wipe it out. So the first step to alleviating that is to just make sure that when you're taking code into your server or when the payload is sent from the front end to your back end server, that on your back end server you're sanitizing that string, or you're making sure to escape special characters or remove your string completely. There's certain caveats to that, like if you have like a WYSIWYG or a text editor and you need to have certain like HTML code in there, then you would have special, like you can use regex or something to strip out things that are malicious.
I think we're good.
Is that it? Good?
Yeah.
All right.